Okay, so in this example, we have three circuits consisting of concentric circular arcs. And each circuit carries the same current in the directions shown. Rank them according to the magnitude of the magnetic field produced at the center, greatest first. So greatest first is important. Let's see if it's gonna, yeah, greatest first is important. Um, so when I look at these, one of the things I notice is that the first one, A and C, that I have current going around and then coming back like in a different direction. So if I think about the magnetic field just produced by if I imagined I had something that was like this, just the outside, right? So I'm going to have a B field when I take my fingers and I wrap them in the direction so that the current is going clockwise, then my thumb points into the page and I'm going to have a B field into the page. So it's going to be like that. And then so this is going to be A, right? And then if I think about this case, inside, I'm going to have a smaller circle where the current is going this way. And so if I wrap my fingers in the direction of that current, my thumb points out. So what that tells me is I'm going to have a B field into the page, but I'm going to have some B field subtracted out of the page. So I know I'm not going to have, I'm going to have to subtract some of the B field here. Same thing is true with C, right? I'm going to have some some X, some into the page, and then some out of the page. But what about B? Well, B, it's going around, um, but it doesn't have anything inside that's canceling it out. So I can think of it like it's the full circle, right? I'm not canceling anything out here. Because I'm not coming back around on myself. I'm still going in the same direction around the circle. And so I would say that B is going to give me the most magnetic field. I'm only going to have, let's see, magnetic field out of the page. So I'm going to say that B is going to have the biggest magnetic field. So I'm going to cancel everything where B is not first. So I only have C and D left. And looking at C and D, or A and C left, so C and D left of choices, but I'm looking at A and C. I'm going to say that that there's more magnetic field caused by the outside of this circle than there is caused by the outside of this circle. And then there's some canceled, but because this is a smaller radius, I'm going to have less magnetic field inside here than I do here. I'm going to have less magnetic field canceled here versus the outside. But I still believe that A is going to give me a bigger magnetic field than C. So I'm going to say that my answer is C.